40, I did give you the option to not enter actual like years. If you don't want to go with the years, I would strongly advise against it. Okay, but I would say if you want to go with 0, for example, so years after 1996, 1996 itself would be 0. 1998 would be 2 because it's 2 years after 1996. So you have to be very careful that you match this to the starting point. So basically, if you want to go 2004, you go 2004 minus 1996 to get the 8. You know it's 8 years since 1996. So I will discourage you from doing this. I say just type in the actual years, which makes it a bit tricky. Okay, so I don't know if you've tried it, you know what I'm talking about. So I already have these in here. So I'm just I have them in L5 and L6. Maybe this is a trick that I should tell you about. So I already entered all of this in there. I'm going to go to L1. Right, L1, and I'm just going to say, I'm going to go second 5. And I just say, hey, L1, whatever's in L5, I want it in L1. And whatever is in L6, second 6, that's what you press. It just copies everything in there. So then I don't have to like sit here and just type it in all individually. Okay, so L1 and L2, that's what these numbers represent. So for graphing purposes, I would go, okay, let's see here. Let's see if you remember. If I go zoom stat right now, let's try zoom stat. Doesn't do anything for me. And that's because if you go to y equals, plot 1 needs to be turned on for zoom stat to work. And you probably want to erase all the equations that are already in there. Try that again, zoom stat. This is what that looks like, the scatter plot. And some of you might think, wait a minute, is this a cubic? Is this a cubic function? What is this? This would be a linear situation, right? Like you go, yes, it's a little off, but it keeps going straight into that one direction, okay? So this is a linear situation. Again, keep in mind that I and the province are going to tell you which regression to perform. Like it will say, perform the quadratic regression or perform the linear regression. But there was one year where they asked students justify which regression would be best here. I remember that one year, so I thought that was unfair because you told us you're always going to tell us, right? So that's why I'm preparing you. I ask you to look at the scatter plot. So it's a linear. So then I go ahead and perform, let's see if my history has a linear right there, linear regression. I'm just going to copy paste that.
Excuse the interruption. At this time, we're asking all grade 10s that need retakes. Please make their way to the cafeteria for retakes. If you need your retakes done, please go down to the cafeteria if you're in grade 10. Thank you.
Okay, so this could work for you, but most likely you will have to adjust your window. So let's try this. I wrote down my equation, and then it asked in the year 2006 what will be the distance, right, traveled. So you go second trace value, you put 2006 in your calculator, and in this case it works, it's 86.38, so you don't need to actually change your window settings for this one. But when it says 2026, notice that it's outside of what you've typed in. You went all the way up to 2009. You're extrapolating here. Then second trace 1, x is equal to 2026 is probably not going to work. That's what you're going to get there. So that just means you have to adjust your window. You have to see more into the x max. Okay, so I'm going to quit this, go to my window, x max, I'm going to go 2050 perhaps. Right, just keep looking more this way, and I'm also going to increase it a little bit into my y max. I'm going to go 200 maybe. So then you see more, so the line looks like that. Second trace 1, 2026. Now it's going to allow you to find it. So sometimes it's just a window change, and then it ends up working for you. Okay, so make sure you adjust your window. I will put down next to my key here, adjust window. Okay, so some students think, oh, zoom fit is always going to do it for me. No, not necessarily. Okay, And so that's that. The rest was when, oh yeah, this is what I wanted to talk about. When was D on in your booklet? Did I add D? What year? Yeah, what year? It says actually what year would the distance of 115 be achieved? If you make y2 equal to 115 and find the year, you have to round that one. If it says what year, you have to round to 2039 or 2040, but you can't leave it as a decimal, okay? If it had said how long in years, that's a different story. But what year specifically, you have to round, okay? So round on this one. What if it had said, how many years since 1996 would it have been? If it asked you how many years? Number of years. If it asks you that, you go 20, 39, 34 minus 1996. Okay? That's 43. 43.34. So approximately 43 years. All right. Okay, so type this in. I'm going to go zoom stat. It does look quadratic. Let's perform the quadratic regression on this one. Second trace, no, not second trace, sorry, stat, calc, quadratic regression. Here we go. And that matches my key here. Let's hit graph. Let's see what we can observe on our graph. I want to see more, so I'm gonna change my X min under the window settings. I'm gonna change that slightly to the left, and I'm also gonna change my Y min slightly below. Okay, so there we have it. Is this good enough? Remember intercepts, if there is a y-intercept, it's meeting the y-axis at one point. So I need to see more to the top. So window, I'm going to change a y max to, let's try 1,000. Let's see how that works. Still not good enough. I'm going to keep going up. 1,500 for y max. That is better. Okay, that's better than what I started with. And so what was it, B, that you asked for? C and G. Okay. So I guess I'm going to have this on here. For B, what's the initial height of the plane? That is, hint, that is your y-intercept. So I found my equation, and just from that, I figured out that the initial height of the plane before the stunt begins is 1,080 feet. Okay, so you would have had to adjust your window at some point to figure that out. C, how long did the stunt last? Okay, so that is a good question. I'm going to highlight that one. And we may have to look at our question to figure that out. It says here at the top, let's go back to the question. An airplane performs a stunt at an air show. It consists of a sudden drop followed by a rapid increase in height. The stunt ends when the plane reaches its initial altitude, its initial height. So this basically is, we are originally at 1,080. The plane drops and then goes back up. And once we reach 1,080 again, that's when it's over. So technically, what we need to do is we need to go y equals, we make y2 equal to 1,080. And we're going to draw our line. And so it starts at time 0, and it will end when it reaches 1,080 again. So I have to increase what on my window to make that happen? X max. That's right. So let's go to our window. And I'm going to double whatever is in here, maybe a little bit more. I'm going to go 35. And there it is. It's when it reaches this point again, it's over. The stunt is over. So it starts here, drops, and then reaches here. So we have to find this time right here. So second trace 5. I'm going to go closer to that. Enter, enter, enter. So it's 19.599. So it's 19.60 seconds. So we're going from 0, 1080 to 1960, 1080. So that's the answer. Does that make sense? Okay. And which other one? G? F and G? Just G. G. How long was the plane at or above 800 feet? Okay. So I will show you this. Y equals, I'm going to make Y2 equal to 800. Okay. And I'm going to hit graph. So it wants what? The time it was above this, right? So basically this little stretch and this little stretch here, right? Because let me put the 1080 in there as well. Sorry guys. I'm fighting something. Okay, let's try this again. So we basically want to know when the stunt starts here, we want to know this time and that time. Okay? It's too much work, in my opinion, to figure out this little stretch and this little stretch. So instead, what I do is I find these 2 points here, the 800 marks. And that's what I write down here. So I let Y2 equal to 800. I find intersection. The first time it reaches 800 is here. The second time it reaches 800 is there. So I subtract these two numbers, and this gives me the time below 800. And I'll explain this again, right? If you subtract these 2 times, guess what? The plane was below at these 2 times. So when you subtract, you find below. Okay? But it wants the time above. So I take the time below. Here, I'll highlight it. I'll take that time below and subtract it from 1960. Why 1960? That's the total time spent in the air, right? The stunt time. So I go total minus time below. That gives me the 3.33 seconds above. Does that make sense? It's a lot of work. Can I just remind you of this? When you subtract, ask yourselves, what is happening between the 2 numbers that I'm subtracting? Like if you subtract from here to here, if you subtract these 2 numbers, oh, that's the time below, right? Like what's happening in between, you are below it. If this curve had pointed this way, if the stunt had started down below and went up and then back down, if you subtract the 2 times, guess what? That would tell you the time above the 2 points that you're finding. So it depends on which way it's pointing and what's happening in between the 2 points. Does that make sense? Okay. I'm glad you asked questions. Keep asking. Any other questions? Okay. There was the gas prices. This one, in my opinion, is so tedious. I would probably not do this on a test or a quiz or an exam because, look, there's like all these years, so you have to enter all of this into L1 and L2, and you continue it over here. And if you make one little mistake, you type in one number wrong, then the whole thing is off, right? But that was a cubic one, so that's something to try out. 43, let's go to 43. I want to do that with you guys.